I tend to think that they're complete zombies.
Okay.
Um,
So that's
so I
not
don't think they
conscious.
have
Is complete.
any conscious experiences.
Did I read that you think fish have no conscious vision? Because I think
Yeah,
this is hilarious and bizarre, and I need you to explain it. Because I just spent the last
yeah.
week
So
scuba diving in Thailand, and there's just hundreds of giant schools of fish everywhere. And I was like really replaying these scenes in my memory as I was reading this, and I was like, how could it be possible that these really big, gorgeous animals don't have any experience of their visual system? So basically, you think they're operating by
yeah,
blindsight all the time. There's sensory information
exactly.
coming in, and it's impacting their physiology, but there's nothing. There's no visual experience of what it is like to be those fish ever.
Yes, yeah,
That's
like
so
blindsight.
bizarre. That's so weird.
So here's one way of thinking about it. Uh, the idea starts with okay, what do we have conscious vision for? All right. So what's the role of conscious vision? Why would an organism have conscious vision instead of having just unconscious vision, which we know is a thing? So uh, the story goes like this. Um, First, a, a, a clue, we can get a clue as to the function of conscious vision by looking at how fast conscious vision occurs. So what does that mean? Well, think about the fact that when I show you something, it can't possibly be the case that you see it immediately consciously. Okay? It has to be the case that the signal reaches your retina, and then it takes time for the signal from your retina to go to the, I don't know, the lateral geniculate nucleus and all the subcortical areas. Then it goes to V1, and then from V1 it's further processed. Okay, and so whatever you think, conscious vision cannot be immediate. So it takes time. Now, Steve Fleming and I have been arguing that conscious vision can be surprisingly slow. It can be surprisingly slow, on the order of 350, 400 milliseconds in some cases. What that tells us is that, of course, we are not claiming that vision is slow. Okay, of course, you can react to objects and events much faster than 350 milliseconds, right? Especially if there's a looming stimulus, for example, you're going to blink extremely fast, much faster than that. So that means that those fast reactions to visual stimuli have to be driven unconsciously. And there's a lot of evidence that fast reactions to visual stimuli are driven unconsciously. In general, vision for online action guidance seems to be unconscious. So there's good evidence from Milner and Goodale, who have developed the idea that we have two visual systems, one dedicated for action, online action guidance, and the other one dedicated to categorization. And one of those is conscious, the one dedicated to categorization, and the other one is unconscious. You get beautiful dissociations between those two, in some cases of some illusions. A good example of this, I'm going to mention it because it's fun, um, occurs in the hollow face illusion. So in the hollow face illusion, you can make a concave face appear convex and vice versa. If you look at the illusion on the internet, you're going to see beautiful examples. It's really quite striking. Now, if what Mel Goodale and his team did was that they put, so they created a 3D version of this illusion, and then they put targets on those faces. Now, they had two conditions. One condition was to evaluate the distance between your hand and the target. Okay, so you manually estimate the distance between your hand and the target. And of course, if you do that, you see the effect of the illusion. People think that the target is farther than it actually is when it's put on the cheek of the face, for example. And in another condition, they asked the participants to flick the targets off of the faces. And when you do that, you don't see the effect of the illusion. Okay. So that's one of those illusions that uh, trumps vision for categorization and conscious vision, but doesn't trump your hand, so to speak, doesn't trump vision, doesn't fool your unconscious visual system.
Yeah, really
In any
cool.
case,
I hadn't heard of that
this
one
is the kind
before.
of
I love illusions, so please feel like you can drop any illusion, and I'm obsessed with optical illusions of all kinds. That's an interesting one. I didn't know. So they were able to separate the two visual streams and actually see how a difference in action and a difference in engagement with the illusion creates a different effect. That's very cool.
exactly, and
Yeah.
you get plenty of effects like this. Now, there are some of them are somewhat controversial, because in some cases the different tasks are easier or harder. But putting that aside, you get plenty of dissociations between vision for action and conscious vision. Another good example is the work of Marisa Carrasco, which is not related to vision for action in particular, but related to eye movements. So it turns out that your eye movements most of the time are driven totally unconsciously. Um, One way to see this is with a phenomenon called binocular rivalry. So if you show to one eye gratings moving this way and or horizontally to the right, and then to the other eye you show gratings moving down, uh, you're not going to be conscious of the fused percept. You're not going to be conscious of gratings moving down and to the right. Instead, you're going to be conscious of gratings moving to the right, then down, then to the right, then down. You're not conscious of the fused percept. You're conscious of one, then the other. However, Marisa Carrasco and Miriam Spearing discovered that your eyes follow the orthogonal direction. Okay? So your eyes somehow are driven by the fused percept, but your conscious experience has only one at a time.
Ah, very
So there
cool.
are plenty of dissociations like this one. Another one that's pretty cool is, so if I show you a stimulus and then I mask it by putting something around that stimulus, you're not going to consciously experience the stimulus. However, suppose I create two conditions. In one condition, I show you the stimulus and I ask you to answer as fast as possible. And in the other condition, it's still the same. You have to answer as fast as possible, except the stimulus is masked. So now you don't see it. Your reaction times are the same in both cases, okay? Irrespective of how well you saw the stimulus consciously. So that means that the initiation of action has to be driven unconsciously before you consciously experience the stimulus. That's an effect called the Ferrer-Rad effect that was discovered in the 60s. In any case, all those cases seem to indicate that when you see something, it's first processed unconsciously and can drive your actions in various ways, even if you're not conscious of the stimulus yet. And then conscious experience happens later. Now, what does this all have to do with fish?
With fish,
Um,
with my
so,
long-nosed emperor fish. I want to know what's up with these
yeah.
guys.
So, sorry, the story is a bit long, but that's the
No, it was cool.
introduction
You
to the
gave a
story.
bunch of cool examples. Don't worry.
Now we are at the place where we've learned something. We've learned that conscious vision is not for fast, immediate reactions to visual stimuli. So, for example, imagine that you're driving on a foggy road at night. Things, as you're driving, even if you don't drive fast, will enter your sensory bubble, so to speak, at the last minute. Okay, you can't see very far, and therefore things will enter your sensory environment, your sensory horizon, at the last moment, and you'll just have to react very, very quickly because of that, right? So the farther you see, the more time you have to react to threats and opportunities in your environment. If you can't see very far, if things just appear in your sensory horizon at the last minute, you'll have to react very fast. Now, we know, for the reasons I described, that those kinds of fast reactions are driven unconsciously. Uh, so that's something Steve and I were interested in. And then Steve Fleming told me about the work of a neuroscientist. Well, he's doing many things besides neuroscience, uh, named Malcolm McIver, who has fantastic work on what he calls sensory horizons or sensory bubbles. And the idea is this: because of the way light is diffracted in water, you cannot see very far underwater. Okay, so the idea is you have computational models that seem to indicate that aquatic animals, including fish, cannot see, at least for ecologically relevant objects, cannot see ecologically relevant objects farther than a few body lengths ahead. Okay, now that means, just because of the properties of water and because of the properties of their visual system, that means that they have to react very fast to threats and opportunities in their environment, a bit like in the case in which you are driving on a foggy road at night. Okay. Now it depends a bit, on the time of day, where exactly they are. If they are close to the coast, it's not the same thing as if they're in the pelagic zone, so far into the ocean, away from the coast, and so on and so forth. But in general, as a rule of thumb, it's 2 to 3 body lengths ahead. And so the idea is, because of this, they have no use for the kind of visual capacities that we know are associated with consciousness in us. Okay. Uh, and as a matter of fact, if you look at the brain areas that process vision, they have brain areas that in us. So, of course, we've evolved from we have a common ancestor, and the brain areas, the subcortical brain areas that we have, are somewhat similar to the brain areas that are responsible for many vision-based behaviors in fish. And those behaviors we know in us are driven unconsciously.
Interesting. Interesting. So I can see, I see parts of the argument, but it seems a little crazy. No, like to say that would you be making the claim that all fish are like this, or particular fish that are in low visibility environments? Because again, I was scuba diving in Thailand, and you can get like 40, 50 meters visibility. Like, it's beautiful, clear waters. I was out in the Andaman Sea. It seems like these fish, if they had functional conscious visual systems, would be able to see for 40, 50 meters, and it seems advantageous that they could do that, because some larger more predatory type fish could come towards it or something. I am Yeah, I don't know. It's a funny idea. It's a really interesting one. I could totally buy that not all fish have conscious visual access, but that some do. Do you think that would you be satisfied with that answer, that some of them evolved that because they were in higher visibility waters, more sophisticated, larger visual infrastructure, but then some don't? Is that a halfway point that might satisfy, or are you dogmatic that no fish has this?
So I think that no fish have conscious vision, but my uncertainty varies depending on the kind of fish. Um, so the story I gave is a story according to which conscious vision is not for immediate reactions to visual threats and opportunities, but it's for thinking on the basis of vision. So once we come out of organisms come out of the ocean, they can all of a sudden see extremely far. Okay, and with the evolution of the neck, it's also a huge improvement in sensory volume, because now you can have targeted eye movements and move your head and so on and so forth. So if you take the sensory volume, get a millionfold increase in the sensory horizon. So you can think about what you're going to see. Now, there are amazing capacities in fish, but they don't seem to show the kind of model-based planning that we're able to do on the basis of vision. Now, the story I gave is a story on which it only depends on the sensory horizon, namely as how far you can see. But that's an approximation. Another factor that's very important is visual clutter. Uh, so, for example, if the environment is kind of complicated, you have conspecifics or predators that can hide behind behind occluders, then that's going to lend itself to the evolution of planning capacities based on vision, even though the sensory horizon is limited. So that might there might be cases that fit the bill. For example, octopus might be a special case of aquatic animals, but because they encounter a lot of visual clutter, might have developed planning capacities based on vision for that reason. Then for coral reef fish, it's also a bit more complicated, again, because of this issue of visual clutter. And also, they tend to be the smartest fish, so to speak. So I'm more strongly confident for fish that live in the pelagic zone, so away from the coast, or at least spend a lot of time away from the coast. Um, yeah, so that's where I'm more confident. Note that evolutionarily speaking, it seems like the evidence indicates that fish first evolved not far from the coast, okay, and then moved away.
So, if it's possible that fish don't have conscious vision, what do you think they do have a conscious experience of? Or is there, like, how confident would you be that they don't have any conscious experience, that they are fully unconscious biological organisms? Like, do you think that they do have a sensation, that they have an experience of what it is like to be that long nosed emperor fish?
Um, I tend to think that they're complete zombies.
Okay.
Um,
So that's not no,
so I
not
don't think they
conscious.
have
Is complete.
any conscious experiences. Um,
Interesting.
but I'm most confident for the case of vision because we know so much about about the difference between conscious vision and unconscious vision. You could have two stories. I mean, one possibility is that consciousness first evolved um, uh, independently of vision, right? And independently of the emergence of model-based planning. And so maybe fish have that kind of consciousness. And then vision was recruited into consciousness, so to speak. Um, I don't really buy that because I think there's a lot of evidence indicating that consciousness really seems relevant for model-based planning um, and metacognition. So I don't think fish have any kind of have the relevant kind of metacognition, and so I don't think they have conscious experiences. But I'm not as confident as in the case of vision. I'd say my credence is 60% or something that they're completely zombies. Yeah.
I'm slightly worrisome of the extrapolation that you could make if you assume that fish don't feel pain, right? Pain is, conscious pain. If there's a lot of there's a big movement at the moment to stop things like cooking and boiling lobsters alive and boiling crabs alive. Do you think that in those cases where moral well-being is at stake, we should be very, conservative with that, and assume that they're conscious, because there is a chance that, even if there's a small chance, that we are, submitting them to quite a lot of pain that is not a good moral thing to do. And I'm kind of worried that about the idea of that fish aren't conscious, of what people might take from that.
Yeah, I mean, there's a big distinction between what you believe and what the evidence indicates and how you should act. In many cases, you might think, oh, even if I have 60% credence that fish are complete zombies, maybe there's a. Usually, I think, well, 60% for complete zombies, 35% for they're conscious and 5% for there's no fact of the matter. um, that might be another option. Peter Kelsos, for example, defends this. Now, even given this, so that's what I believe. But then, even given this, you might think, well, 35% chance that they feel pain is enough to justify caring about them. And, there might be a precautionary principle of the kind that's been advocated by Jonathan Birch, for example,
Right.
saying, in cases where we don't know, the good thing to do might be to to be careful, right?
Exactly.
So that might be sufficient. What I don't think is correct is to change what you believe because it would have potentially bad moral outcomes. So, for example, I'm not going to invent evidence where there's no evidence just because I want to to make sure that people don't hurt fish, for example,
Sure.
right? I think we should um, keep separate what we believe and then how we act based on what we believe and
Right.
what the evidence indicates, and then how we act based on what the evidence indicates. And what's true is that it's very, very much uncertain. It's very much uncertain. So people who think that fish have conscious experiences should also acknowledge that that the issue is very much uncertain.
Yes.
Um, I think I remember a poll that was done at the Association for the Scientific Study of Consciousness, maybe in 2019 or 2018. So every year there's this big conference about consciousness, and I think fish consciousness was still was trending towards the majority view, but it was still not totally a consensus view.
I'm curious. I want the listeners to comment below if they think fish are conscious. I'm curious what at least in my audience who are listening, if it's over 50%. I could keep talking about fish all day. I really think this is fascinating, but I really want to move to aphantasia. So I know
Sure.
you've done some. I know you've written some papers on aphantasia. I find this completely fascinating. I've been lucky enough to speak to a bunch of the largest aphantasia researchers, like Adam Zeman, Alfredo Spagna, Merlin Monzel. I just think it's so fascinating. The Giant Shoulder mission is to explore radical ideas in biology, neuroscience, and consciousness, and elevate those stories to the highest possible level while keeping them accessible to everyone. If this interests you and you want to support independent science, then please consider subscribing to the Clips channel